Hello everyone, welcome to this week's video. This week you learned about mediation and moderation. While the concepts of mediation and moderation is important to understand, running the actual model needs very advanced statistical skills. Like you have read in the slides, it used to be a very complicated computation effort to run mediation or moderation analyses. But nowadays, we have a very useful tool that Dr. Hayes created. So what Dr. Hayes did is that when you hypothesize a model where you have mediators or moderators in between an IV or a DV, he created various versions, more than 90 models, and numbered them all. And he provided a macro for each model number. So now all you have to do is find the model number and then match the number uh, with your hypothesized model. And we will practice this more in the following module. But in this week's module, you will learn the basic mediation model number 4, and the basic moderation model, which is model number 1. So let's begin. So you have to first download process macro zip file. You can download on these websites, but I created a direct link which will download the zip file directly. So you can click this link and it will download the file. So if you look at your downloads folder, it will show that this new process file is downloaded, right? So you can unzip this file to wherever you want. And if you go into the file, it'll have lots of information like where you can find the model numbers, and there's different macro programs for different statistical software, but we're using R, right? So you'll go here and you will double click this, run this file in RStudio. So this is how I ran it I got it on RStudio just by double clicking it. Another way to do it is open a file. Yeah, first you gotta extract it, right? So if I would extract this file and if I would open this file here using the RStudio interface, it will also give you the same thing. So either way, you will have this process script loaded to your RStudio, right? And if you select all and run it, it will have process macros installed to your RStudio. After you have installed this process macros into your RStudio, you get to use this process command in R. And with this process command, you can run every Hayes process model, conditional processing model. So it's a very powerful tool that you can run any type of conditional process analyses. And I provided some link. So if I would search Hayes process models on Google, like it has model 4, model 1, all different numbered models, like model 2, all different model numbers, right? 14. You can find all different models. Like here's model 84, right? So what you will do is you'll find which model number matches the hypothesized model that you are working on for your final project, right? And then you will run that process model in RStudio. And this is what we're going to do next week, actually. But this week, we're going to just run model 4 and model 1. All right, so it looks like process is now ready to use. Once you got this um, output, then you are ready to run process. But before we do that, we gotta choose which data set we want to use, right? You can copy and paste this to a script, and we don't need to install it because we already have it, but we can run it from here. Or you could just select the file from your home window and import the data. It will load the library and make it read Excel file from this file, right? So it's the same thing. If I would import it, then now I have our dataset file loaded to our RStudio, and we can run all these different process commands. So let me show you how to run a mediation model, which is model 4, in our example. So if you saw the slides, the basic mediation model is model number 4. So there was a conceptual diagram of mediation, which is model number 4, and a statistical diagram for it. For moderation, we had a conceptual diagram like this and a statistical diagram based on these calculations. So that's how you identify the model, and we will run the basic model number 4. And the model we will run is testing whether preseason hope mediates the effect from team ID on flourishing. So you got to start typing process and open the parentheses. Then you will see that it will ask you, what's your data? What's your dependent variable Y outcome? What is your independent variable X? What is your mediator? What is your moderator? So on and so forth. What are your covariances? What is your model number? What is your convergent rate, iteration rate? So on and so forth. You can check all these commands in one of the modules I created on Start Here folder, which you saw in the first week of in this class. There are many commands that you can use to run process, but we'll use the only ones that we need. So you can see that process asks you to designate your data, right? So you select data equals, then you put in the file name, M7 SPMT. This file is already loaded, so we can choose this file. And then it asks you, what is your Y dependent variable? Our dependent variable is flourishing, right? Flourish. This is our dependent variable. Then it's gonna ask you, what is your X variable? So we gotta type in team ID. And then we have one mediator in model 4, right? Our mediator is pre-season hope. And make sure you get all the uppercase and lowercase capitalizations correctly, or it will not identify the variable names. And our model number is where we have one ID, IV, one DV, and one mediator. The model number is 4. And we want it uh, we want descriptive information of our model. So 0 is um, default. So if you want descriptive information, you should check 1. So it's asking dichotomously. We also want standard deviation results. So we got to set it as 1 because default is 0. All right, so let's run this process command. So it's saying that team ID average does not exist. Oh, I got the capitalization wrong. It's all small cases. So I gotta fix that, like I told you. And every mediation analysis and process is ran by bootstrapping. And bootstrapping is kind of creating sub data sets like 5,000 times and calculating the confidence intervals in that way. So it takes a little time. So you got to wait for mediation bootstraps, and boom, we got our results. You can see that the results are the same as shown on the slides. So it shows you the variables that you designated. We designated flourishing as our dependent variable, team ID as our IV independent variable. We had one mediator preseason hope in our model. It shows how many samples we had, and it gives us the descriptive stats because we ask for it. We put 1, and it will have standardized coefficients calculated as well because we ask for it right here. So let's look at the first regression table. So the first regression table is for preseason of our mediator. Every variable that receives an arrow in the conceptual diagram has a outcome variable regression result. The model summary shows that the R square was 20, based on the R square, 24.42% of pre-seasonal variance were explained by team ID, and this was significant at a p-value smaller than 0.001. So the overall model was significant, and since we have only one variable, also is the individual slopes significance was significant as well. And the coefficient was 0.3574. So for one unit different in team ID, there was a 0.3574 increase in preseason hope. And when we look at flourishing, flourishing receives 2 arrows from our IV and our mediator, right? So it has 2 predictors where showing where team ID was significant, but preseason hope was, sorry. Yeah, both were significant, right? Both were significant, but the coefficient of team ID was smaller than preseason hope. So in basic mediation conceptualization back in the days, we used to call this partial mediation. If team ID's effect on flourishing was non-significant and only the mediator was significant, we would call it a full mediation. But if both direct and indirect paths are significant, we call it partial mediation. That's something a little bit more conceptual than the scope of our class. But now we're pretty happy because all the paths, coefficients, and especially the paths going through preseasonal, they were both significant. So what follows all these regression results? Of course, we look at the overall model first, right? The R square was 0.1531, 15.31% of variance in well-being flourishing was explained by these 2 variables. So following these regression tables is the bootstrapping results. It gives you the results for the direct and indirect effects. So direct effect is the arrow coming directly from team ID to flourishing. This is identical to this. However, the indirect effect through preseason hope is calculated based on both this path and also this path. And when we look at the results, the coefficient was 0.0718, and the indirect effect based on bootstrapping gives us a confidence interval. So we have to see if the confidence interval's lower level confidence interval and upper level confidence interval does not include a zero. Here, both confidence interval, lower level and upper level, were positive, right? So zero is not in between these confidence interval, but before it. If both confidence intervals are negative numbers, then it will also be significant as it does not include a zero, and the zero is outside of this range. If one confidence interval is negative and one confidence interval is positive, then a zero is included within its range, right? In that case, it is not significant. Okay? So here we have a significant mediation effect, and we're very happy about it. And why we are more happy is because if we compare the size, the effect size of the indirect effect compared to the direct effect, we can see that um, the direct effect is smaller than the indirect effect, which means that how people identify with their favorite team, sport team, and how that increases a person's well-being is not just directly through not just directly because of the function of team ID, but more through a person's preseason hope. So based on our sample, this data was collected before the football season started at Texas A&M. So people's level of well-being were from based on their identification with their football team was more affected positively through their level of preseason hope than just the direct effect from team ID. The indirect effect going through preseasonal explain more. So how does team ID increase people's well-being level? We saw that the indirect effect through preseason hope was more had a larger effect compared to just the team ID. So this is how you run a mediation analysis and also interpret the results. So now let's run a moderation model. So here we're going to use a different DV, right? So I'm going to open a new process. Oops. I'm going to start a new process command. Our data is the same. This time I'll just copy and paste it. I typed the previous one to show you how you can do it directly. But a more easier way, of course, is to copy and paste it. And you saw that the commands are very sensitive to the capitalization of each word. So once you put all the commands for your process model number one, which is the moderator model. So you can see that we don't have a mediator in model number one, right? So we don't need to insert the M command, but we have a moderator. So we use the W command to designate the first moderator. We only have one moderator in model one. So the moderator is agreeableness, and our IV is the same. The DV has changed to attendance. And we ask for descriptive stats and we ask for plot code. I'll show you how to use the plot code real soon. So bear with me. So let me run this command. It will give you a really quick, much quicker response because this time we didn't need to run the bootstrapping. All right, so if you would see the results of our new process command, it shows that we ran model number one. These are our variables. We have the sample size, we have the descriptive information, mean, standard deviations, and we have the correlation matrix because we asked for it. We asked for it here and describe one, right? And it gives us one regression results because you see that the only attendance received arrows. In model one, if you remember, the model one arrow is not headed to the variable, right? It is headed to the path. So since there's only one variable that receiving the arrow, uh, it only shows one regression result. If there were multiple variables receiving arrows, there will be multiple regression tables reported. Okay, so our R square value is 0.2675, meaning that team ID and agreeableness and its interaction effects explain 26.75% of the variance in our attendance. Um, and it was significant, right? So we're very happy about it. So, and when we look at the results, all of the paths were significant. Agreeableness had a little quite larger effect than team ID. So if you're an agreeable person, you have a more higher tendency to willing to go to the games. And our interaction effect was negative. This tells us that there's a disordinal interaction. If there's an ordinal interaction, the number would have been positive. So it's really difficult to grasp what a disordinal interaction really means, or it's really difficult to interpret it, right? We're all happy because it was all significant, right? This is a more um, uh, uh, information about adding this interaction had a significant R square change. The R square increased this amount. So about 1.42% variable was more variance were more explained by adding this interaction term, and it was significant. So we're happy about it. And since it's difficult to just understand what this means, process gives us the conditional effects. So we call this spotlight analysis sometimes because it shows conditional effect shows how the effects are, the effects from team ID to attendance, how those are based on the moderations levels. So here, agreeableness is the lower percentage, I think is like a 16th percentile. People, 16th percentile of agreeableness was people with agreeableness of 3.5. So I'll just call these people lower agreeable people. I'll just call this median agreeable people. And this is so this is the 15th percentile, the median. And this is, I think, based on my uh, based on the top of my head, this should be like 84% percentile. I'll just call this highly agreeable people. So the effect of team ID affecting attendance was higher for lower agreeable people. For higher agreeable people, the effect of team ID was lower. So how can we interpret this? To interpret this more easier, we would like to visualize this. But since I'm quite an experienced researcher, I can see right away that highly agreeable people, they don't need a high team ID to attend to the games. Uh, while lower agreeable people, team ID matters more. So for lower agreeable people, team ID should be high, and for high agreeable people, it really doesn't affect a lot because I can see this based on the data pattern. And this is the um, plot information that a process generates for us to create visualization. And I'll show you how to use this. There are many ways to use this, but what I like to do is uh, have you guys experiment your ChatGPT or generate any type of generative AI to create a code for yourself. So you see, this was an example prompt, right? So we're asking AI to create a script using ggplot2 to visualize our interaction. And the interaction information that we got from asking this command is this: data for visualizing the conditional effect of the focal predictor. So it is identical to this information. And I will just copy this part and I gotta create a prompt first. So we're gonna use ggplot2, right? So let me check if ggplot2 is selected in our packages. It should be because we did it last week. ggplot2, yeah, it's here. We just have to load it to our library. So we got it. We got this ggplot2 ready, and I'm gonna use this prompt here. And all you have to do is copy and paste the data. I'm going to copy and paste all this information here. And let's see what Gemini provides for me. So Gemini did all the tedious work that I should have done to kind of code all these information to create a plot. So that's why I like to use AI for coding. So let me just copy and paste everything. We already loaded ggplot, right? So let me just copy it from here. And let me start on line 11. And I'll just drag from line 12 to the end and run and see what I get. All right, so let me just enlarge this screen. So it shows me, it created this plot and I like it. So what it gave me, and you can like save this file, right? What it gave me is that it created three conditional effects for three agreeableness level: lower agreeable people, median agreeable people, and highly agreeable people. As you can see, for highly agreeable fans, the effect of Team ID on attendance, the slope was the least steepest, right? So the effect was the smallest, which is identical with our results, right? For the highly agreeable people, the linear effect of Team ID on attendance was the slope was weaker. But overall, their attendance level average is high, and that makes sense too because like agreeable people have higher attendance tendencies, right? So next we have median agreeable people and we have lower agreeable people, and you can see that the slope's angle is the steepest for lower agreeable people. So for lower agreeable people to come to the game, they have to have high team ID. As you can see here, people with low team ID had the least attendance intention for the low agreeable people. Even though you might have a low team ID, if your agreeableness is high, then your attendance intention was pretty high. And for high team ID people, there were not a lot of change here. But for low team ID people, the change was more drastic across three levels of agreeableness. So based on this information, so this is the interpretation of the results. And if I would discuss this for manuscript and provide practical implications, like um, for if you want lower agreeable people to come to the game, you got to induce some uh, social identification salience. You gotta make people more think and feel and kind of remind about their identification with the team for them to have higher attendance intentions. So maybe I would suggest practitioners to focus their strategies on lower agreeableness people and how to stimulate their team ID. Because like high agreeableness people and high team ID people, they will come to the game anyways. So maybe focus more on lower agreeable people because team ID is more important factor for them. So this could be one kind of a example I could provide in how you run the data, interpret the results, and then write a discussion about it. And this is what we will be doing with your model. And that's what we're going to start doing next week. So I hope this demonstration helped you understand and kind of going through all the process helped you work on this week's progress report. So after you have done this, save all the outputs and copy it into a Word document or anything and submit your progress report for this week. And if you are interested in process in R, there are more information here. There's more information on our module. Like here, oops, I have made a page for all different type of R, process commands, what it means, the descriptions of it. So there's much more to explore. All right. So this is this week's demonstration video. Let me know if you guys have any questions, and I will meet you in our next module, in our next video. Thanks.